is the name of his presentation. Thank you very much. First of all, let me tell you that any similarity with the truth and the issue of the presentation, the topic of the presentation, is mere coincidence. Let me start describing a typical day when we work as developers. Normally we get a task to do and we think how we can implement it. We run some tests, implement some new things, we revise the code, and then we do the deploy to production, and then we have the feedback from the client. Now, very often we really think about performance and how our changes affected the user's experience. Now, why is this important? Why is performance important? Because this is important for users. For example, think if you go to Google and ask a question, and it takes more than 1 to 2 seconds, then you start to think, well, they have no internet, you look if Wi-Fi is on, what is wrong. And the same with the results. You open new tabs, the one that opens up first is the one that wins. If another tab takes a bit longer, well, forget it. So users care about speed. And the Nielsen-Norman group, which is user experience, says something that is very similar. Up to 100 milliseconds is the computer response in less than 100 milliseconds. I have instant preference. If it takes up to 1 second, it is fluent. The computer is doing something, but if it takes between 1 to 10 seconds, I just don't like it very much. I think, well, what's going on here? Now, if it takes longer than 10 seconds, well, you sort of get distracted, your site will no longer be visited. And my wife was telling me this afternoon, she said she worked in design, and there are some sites that are excellent, are wonderful, but they take so long to load that I don't even go into that site. It takes far too long. But in spite of this, in 2011, Google measurement said that 5 seconds was the average time to load an app, a web application. And that's quite a long time. And a study from the Nebraska University said that the tolerance has dropped to 2 seconds. If it takes more than 2 seconds, then your application will be a slow experience. And this is important because it also affects our business, not only because users care about this, but in Google search in 2006, after a survey, they said, well, let's show more results on the research page. This went from 10 to 30. And a couple of days later, they realized that traffic had dropped 20% and said, well, they started to research, well, what happened here? Why did this drop so much? Because this is something they asked us to. And then, in fact, they realized that it took half a second longer to show the page, and that is what affected the drop. In 2011, they did a more controlled study, and then the result was even worse, because 400 milliseconds slower showed that there was less traffic, half the amount of traffic. And you know that for Google, these are millions of dollars that sort of get lost because they live from the publicity. In addition to this, Google shows the speed of your site as a feature in their ranking. So if you have a slower site, then it will be lower than the one of your competitors. Amazon conducted a study in 2006 and said that if your web took 100 milliseconds more, you would have a drop in 1% of your sales. And according to the official report for 2006, this was equivalent to $107 million less in terms of sales. So if we're to improve our application, how can we go about this? First, we have to measure. We have to have a starting point. Then we can optimize things, and it is important to do tests, unit tests and functional tests to see if those changes did not affect the application. And I will give you a couple of tips that I learned along the way. So measuring is essential in order to determine if your change was positive or negative. If you do measurements and this has the same results every time, this won't lie to you. So if you know that if you measure things, you will know exactly how much you improved. It is also important to use real data and volumes and to be clear as to where we want to go. It happened to me with a client who received messages on a devil and had a demon losing, and it sent also certain notifications. So I was asked to repair a bug, and it worked, and I put it back there, and after a couple of minutes they sent back the ticket, said, well, this is far too slow, the demon is behind there, so it cannot work in that way. I said, well, what happened here? I hadn't used real data, and the first thing that you have to do is to measure how long the process took in the past, and after having fixed things, my solution had took less time. Now, there are three different ways of obtaining the metrics. One are concurrence tests, which basically involves various concurrent users accessing your site and see how your site responds. And an application that I can recommend out is Apache JMeter. This was very useful. So you can use it in any operating system, and you can send the test to someone else to run them, and it works very well. And this allows us, for example, in the application use, I could identify that the landing page took more than 1 second, and when we loaded it, it took far longer. So when we said, well, we corrected the pressure, and the JMeter said it took only 200 milliseconds. So, and then Apache responded this, so the server didn't even realize. Then you have the benchmarking test. The benchmarking test, check your code a couple of times, and they give you an idea of the processing time, the memory that is used, and you have Rails here. You have the Rails guides and tell you how you can install things. It's not very easy. You have to install a garbage collector to get some information. Then we have the profiling tests. These allow us to conduct an analysis in depth of our code and see other methods that are invoked with the method that we are using, and then which are the ones that take longer. And based on that, we can rapidly see where we can optimize things. Well, a couple of tips that I can give you. For example, the database. As developers, we have a lot of access to this. We have the classical problems as n+1. We have the slow queries and the indices, the things that occur, you can see rapidly. The indices are something I should take into account a lot. And then is the inadequate use of a database. For example, what I was giving you is that you got messages on a table, and then very often, in a couple of seconds, hundreds of messages would come in. And what you were modeling was a messages queue. So you should do a messages queue and not a database. And the same thing happened with Twitter. And when they had performance problems, they switched to message queues. Some interesting tools are, for example, Percona's toolkit. I think there are somewhere around here. You can ask them the PT query digest. This allows us to analyze the slow query log and the quick reviewer MySQL, and it can determine which are the slow ones. And with these tools, you can rapidly see which are the top 10 of the all the slowest. Then you have the query reviewer. Here you can see the output. This is in the development mode. It appears at the top, and then if you expand it, you see the slowest ones at the top, and the one at the top you have the identical queries or other types. For example, you can see things, and if the query is identical, why is it going so many times to the database? Then we have to be familiar with our frameworks and the Rails and also Ruby. For example, in an app that we had, to go from 192 to 193 yielded 50% improvement in the startup of rates. So every time you pick this up for developing and you do the test and you do the deploy to do it twice as fast is much better. And even more if you have a server and you have a new query, then it starts a new instance. Then Ruby 2.0 has an optimization, which is a require and makes a real startup faster. And in some cases, JRuby is faster than Ruby, just because the threads and the not like Ruby, because at one moment there's only one in the processor, and in this case, in our project that we have in Move It, we did measurements. Well, I didn't do the measurements, but the measurements were made to see which was the Ruby version that was best to use with a server that did concurrent work, and the best option was JRuby. Then, to take out the gems that you do not use, when a project has a certain maturity, then you can have gems in the gem files that we thought we were going to use, and they're no longer there. We don't longer use them, so you have to take them up, and then this saves startup time, saves memory space that we won't be using, and the gem file is also very used for using groups. Now we have the development group and the production group, and only use those gems that we need for each environment. For example, in development, we might have the query reviewer or some others that we will mention later on, but maybe they don't want to do them in production, so they won't want the query reviewer in production. Then there are things of Rails that you have to be familiar with, like the asset pipeline. You can use this to improve your performance, and in Rails 4 you have the turbo links. And if you look at Basecamp, apparently this has it already, and it grows very, very fast. And to be familiar with the mailers send the emails in a synchronous way, and to dispatch this through a gem that can do it later or something of the kind. The response receives a rapid communication of what is happening, and in Rails 4, the mailer will be asynchronous, so you don't have to worry about that. Well, the tools that I can recommend for this are the Rails Footnote gem and New Relic. New Relic is a paid version. They have a free version as well, which is very good. But Rails Footnotes, you can install very rapidly. You don't have to create a user, and you can see here, this appears at the end of the page. It adds this here, and it shows typical information in the log and a couple of other things like the JavaScripts, the sessions, the cookies. And here I displayed the query in red. You have this and the database as well. That is where this request spends the greatest amount of time. And then at the bottom I had to cut it because it didn't fit in, but it shows you which are the queries that are being executed. Then the other place where we can optimize things is in the code. If the result does not change, you can cache it. This is related to what I was saying about the queries. If I have 7 queries which are the same, then the result does not change, so you can cache it. So you can validate the cache when it doesn't change. And another application that we're doing in Move It, we had alerts that had to be deployed, and we wanted to refresh. They wanted these to be refreshed every minute or so. So at the beginning, this was without cache, and this crashed all the time. To put a cache there was essential. So the application started to go much faster. Then avoid unnecessary queries to the database. The general design of the solution, the example I gave you today about the messages and the daemon, the first solution that I thought of was not very good. The final resolution was not to go to the database as frequently and to do processing on the Ruby side. So with this we managed to enhance the performance so that the daemon wouldn't stay behind. So we have to think about what things we do and where. to determine which the best solution is. And then a very good tool that I mentioned for profiling is this called perftools.rb, and this allows you, well, you install this in your development environment, and we're navigating, you add a parameter, and then .file.2, and then you have an output like this, more or less, and this shows all the calls that you are doing. This is like the inspection of all your methods, and the largest boxes where your application spends the greatest amount of time with your request, and that is where your application is being executed. The first figure that you have here, 155, is the time that it takes to execute this method and the ones that are called in, and the total figure is how much has been executed from those at the top. Then we have the tests. These are the single tests, functional tests, and integration tests that we have to do. The tests allow us to validate change, the issue of the messages and the demons. The first thing that we said, well, we have to, this has to work. And I said, well, I tested, and the result showed many more milliseconds, about half a millisecond. I said, well, great. Then I ran the test, and it didn't work. I had fixed something that was wonderful for performance, but I had broken the application. So it is essential to have the proper tests. Then all these optimizations that we do to Ruby and the Rails startup make our test far more rapid. If you do testing development or not, when you run the tests, you have to have them very rapidly, and this is important because the development will be much faster. And then I want to speak about Ben Orenstein. This is a link to some of the mails that he sends. Sometimes he spams me, but these come in every about 2 months, and we have to avoid saving objects to the database. He recommends this when we do the tests. If it's not necessary, don't save them. You have to reduce the startup of Rails. He suggests using garbage collector patches, and what I said about the gems. Don't pick up gems that you're not going to use in the new test, and to use stubs for the services and even models that have been tested elsewhere, and maybe you're invoking them in these tests and it's slowing things down. So the performance is important because the user experience is very important, and users want to have rapid applications, and users really prefer to have a rapid application and not a glamorous. And everybody is benefited because if users are happy, our clients are happy, and we are happy as well. Thank you very much.